Hi everyone, welcome to our DBMS learning video. Today we'll talk about a common concurrency control issue in database called the problems of concurrency lost update. What is lost update? Update problem happens when two or more transactions try to update the same data at the same time, but one update gets overwritten by the other. So in short, one of the changes is lost, because the system couldn't handle the updates properly. Let's start with this example. Two friends, Eamon and Zara, are editing the same shopping list at the same time. Eamon adds milk, and Zara removes eggs. Zara saves the list last, and this made Eamon's update is lost. The final list doesn't include milk, even though Eamon added it. This is just like a lost update in a database. Now let's look at a DBMS example using a product quantity, prod_QOH. The current quantity is 35. Two transactions. T1 wants to increase by 100, right pointing arrow should become 135. T2 wants to decrease by 30, right pointing arrow should become 5. In the correct situation, the database handles transactions one at a time. Final value is 105. No updates were lost. Perfect. But now, let's see what happens if both T1 and T2 run at the same time. T1's update is lost. The final value is 5, but it should have been 105. That's the lost update problem. So now let's see how we could prevent this. How to prevent. To avoid lost updates, databases use concurrency control techniques like locking. Only one transaction can access data at a time. Serial schedules. Transactions happen in order. Timestamps. Help decide which transaction goes first. 1. Locking. Exclusive locks. Locking means that when a transaction wants to update a data item, it will lock it so that no other transaction can access it until the first one finishes. For example, the value of prod_QOH is 35. Transaction T1 starts and locks prod_QOH to add 100. While T1 has the lock, T2 cannot read or write. T1 finishes. 35 plus 100 equals 135 and unlocks it. Now T2 starts, reads 135, subtracts 30, and writes 105. Final result. Checkmark correct value is 105, no updates are lost. To put it simply. Locked, sign on a chair, representing the data. T1 sits on it and T2 tries to come, but a sign says, wait. Resource is in use. Locking prevents other transactions from interfering. It ensures only one update at a time. 2. Timestamp ordering. Each transaction gets a timestamp. The database system uses these to decide which transaction should go first, even if they arrive at the same time. For example, prod_QOH equals 35. T1 starts at 10:01, wants to add 100. T2 starts at 10:03, wants to subtract 30. Even if T2 tries to update first, the system sees T1 has an earlier timestamp, so it forces T2 to wait. T135 plus 100 equals 135. T2, 135 minus 30 equals 105. Final result. Correct value is 105. Like in this example. The counter serves the earlier one first, even if the other gets there faster. Timestamp ordering makes sure the earliest transaction always goes first, avoiding lost updates. 3. Serial execution. In serial execution, transactions are not allowed to run at the same time. Instead, they are done one by one, like in a queue. For example, prod_QOH equals 35. T1 completes everything. 35 plus 100 equals 135. Then T2 runs. 135 minus 30 equals 105. There's no overlap, so no data is overwritten. Final result. Checkmark 105, no lost update. Two people, T1 and T2, waiting to use a computer. T1 finishes everything first, then T2 starts. Serial execution avoids conflict by only letting one transaction run at a time. Conclusion. So now you know, the lost update problem happens when simultaneous updates cause one transaction to overwrite another. With proper control, we can make sure all changes are saved correctly. So now let's try this question. Suppose prod_QOH is initially 35. Two transactions run at the same time. Transaction T1 reads the value and adds 100, then writes the result. Transaction T2 also reads the value and subtracts 30, then writes the result. If both transactions read the value before either writes, what is the final value of prod_QOH? A. 105, B. 5, C. 135, D. 65. The answer is B. 5. Explanation. Both T1 and T2 read the initial value, 35. T1 calculates. 35 plus 100 equals 135. T2 calculates. 35 minus 30 equals 5. T1 writes 135. T2 writes 5 right pointing arrow. This overwrites T1's update. This is a lost update problem. T1's update is lost, and the final result is wrong. That's all from us. Thank you. Don't forget to like, subscribe and share.